So next we're going to discuss the fabrication steps. So here we will going to start the fabrication with a blank wafer. Then we will going to build inverter from the bottom up. The first step will be to form the N-well. So in order to form the N-well, it includes certain steps. The first thing is we need to cover wafer with protective layer of SiO2. Then we need to remove the layer where N-well should be built. And we also need to perform some implant or diffuse N-dopants into exposed wafer, and then finally strip off the SiO2. So initially the first step in a fabrication is we need to create a P-type of substrate. Next, we need to perform oxidation. So as we know that this is nothing but a P-type substrate. On this P-type substrate, so there will be a formation of thin layer of SiO2 at a temperature of 900 to 1200 degrees Celsius with H2O or oxygen in oxidation furnace. So the first step is we need to create a substrate. So after creating the substrate, here the substrate is of P-type. Then we need to perform oxidation. Oxidation is nothing but on this wafer substrate, we will going to grow a thin layer of SiO2 at a temperature of 900 to 1200 degrees Celsius. Next, after oxidation, we need to make an photoresistive layer on the SiO2 layer. So here you can see in this is nothing but your SiO2 layer. So on this SiO2 layer, a photoresist layer is formed. So there will be a spin-on photoresist, and as we know that this photoresist is a light-sensitive organic polymer, and it softens when it is exposed to the light. So next we will going to perform the lithography. So here the photoresist layer should be exposed through the N-well mask, and we have to strip off the exposed photoresist. So here we are exposing that layer, so that layer should be stripped off. So next is etching. So usually the etch oxide with hydrofluoric acid. So mainly we are using this in order to seeps through skin and its bone. Next step, it only attacks oxide where resist has been exposed. So it attacks only oxide where the resist has been exposed. Next is we can strip off the photoresist, that is whatever the remaining photoresist is there, that we have to strip off. Then we need to form the N-well. So in order to form the N-well, so we need to diffuse or ion implantation. So the N-well has to be formed with diffusion or ion implantation. So diffusion is nothing but place wafer in furnace with arsenic gas because it is in a pentavalent element, and heat until arsenic atoms diffused into exposed site. Next, ion implantation. So blast wafer with beam of arsenic ions, and ions blocked by SiO2 only enter exposed site. So then there will be a formation of N-well region here. Next, strip oxide. So after forming the N-well region, whatever the oxide it is there on this wafer, so this oxide and this oxide has to be removed. Next, polysilicon. After removing the oxide, so we need to grow the polysilicon. We need to deposit a very thin layer of gate oxide. So and also the chemical vapor deposition of silicon layer. So here there will be a formation of polysilicon. On the thin gate oxide layer, there will be a formation of polysilicon in order to form a transistor. So next is polysilicon patterning. So here you can see that. So this is nothing but polysilicon. This is nothing but polysilicon patterning. So here we are using the same lithography process in order to pattern polysilicon. Next is self-aligned process. So this is after patterning the polysilicon. So we will going to perform the self-aligned process on this gate as well as thin oxide. So here you use oxide and masking to expose where N plus dopant should be diffused or implanted. Then we have N diffusion forms NMOS source drain as well as N well region. So here you can see this. This is nothing but your N source, gate as well as drain region. Next, so N plus diffusion. After forming the regions, we need to diffuse the N plus ions. So here we are going to diffuse the N plus ions. So this is nothing but your source terminal. This is nothing but your gate terminal, and here we'll be having a drain terminal. So historically, dopants were diffused and usually ion implantation, but these regions are still called diffusion. So next, to step of oxide to complete patterning step. So we can remove the complete oxide. Again, we will perform P diffusion. So it is a trivalent atoms by using. So we will going to perform the P diffusion in order to create the PMOS transistor. So similarly, we will going to provide the contacts between source, gate as well as drain region. So cover chip with thick field oxide. Then we can perform etching where contact cuts are needed. Finally, we will going to perform the metallization. So sputter on aluminum. So here we are going to use a metal called aluminum in order to cover the whole wafer. And we will also going to perform some pattern to remove excess metal, leaving pads. Finally, there will be a formation of transistor, that is NMOS transistor with source, gate as well as drain regions.